Students, in this video, we learn how to solve problems on normal distribution. In the last video, I told you that we are converting the problems on normal variable to problems on standard normal variable. And also, we learned about area over 0 to z, that is A of z. The values are given by the table. Table you can see on the screen. Now, first we learn how to find the values of A of z, or it is also called as phi of z. Here, in this thing, you'll notice that we find z value runs here from this 0 to 3.4, and on this point 0 to 3.4, and here you can see that the columns were reading as 0.00, 0.01, 0.02, 0.03, 0.04, 0.05, like up to 0.09. Now, that means we can find the value of E of z or phi of z, both are equal, where z is taken approximate to two decimal places in the form A point BC. Okay, that is only two place of decimal. You get more decimal place, we approximate. Okay, now let us learn how to find E of z, where z is taken in this form. Okay, now let us consider finding A of 0.06. Here what you have to do is, so this is the value of z. Now first we have to consider the value of z to the first decimal place. Here in this case it is 0.0. We have to look for that value in the first column, that is the z column, which is here, which I underlined. Next, look at the next one, 6. That is second decimal place. Okay, that means you look for that 0.06 here. Now we have to move in this direction. Z value 0.0, the first decimal place, and you have to stop once you get 0.06, you come down. Okay, the intersection of this row and column is this value, namely 0.0239. Therefore, A of 0.06 is 0.0239. In fact, we can also find this from the calculator. Okay, fine. Now let us find one more value, A of 1.13. The first we have to consider is 1.1. That is in the first column. Look for that value in the first column. This is 1.1. Next, 0.03. The second decimal is 3. You take 0.03. 0.03 is here. You come down in this one. Okay, and 1.1. You come in this direction. Intersection of these two is 0.3708. Therefore, A of 1.13 is 0.3708. Okay, so I'll take one more example, then we'll move on to the problems. Now, suppose we want phi. Phi India's two different notations. Let us find out phi of 2.20. Now, consider 2.2. Look for that value in the first column. This is, and 0.00 or simply 0. This is one. Come down here, and this is phi of 2.20. That is, this equals to 0.4861. Like that, you can easily find the values. In some cases, you may also require where we have to find z knowing phi of z. For example, in that case, we're not getting the exact value. We come across that later in the problem. Let's consider this. Suppose if we get a of z as 0.4979. How to find z now? Now look for this value in the main part of the table, that is leaving the first column. Okay, so if you get this value, exact value, fine. Otherwise, take the value which is near to this. Here you can find that 0.4979, which you find out here. 0.4977 you find here. Next highest value is 0.4978, and you got 0.4979. Exactly that value find here. Okay, then what is this? It is the thing about a of, what is the value of z? You go back in that line to the first column where you find 2.8. So write a of 2.8 and go back in that column and you find 0.06. Therefore, 2.86. That means here z equals 2.86. Like that, you can look into the table. Okay, that's how you have to make use of the table. Knowing z, you can find a of z, and knowing a of z value, we can also find out z. Now, I'll take one more example of finding z knowing a of z, where we approximate. Okay, for example, if something you are getting a of z as 0.2715. Now, so you have to find out z. So, in the main part of the table, look for the value which is equal to 0.2715. Now, not getting that in this table, but you find the value near to that are 0.2704 here. Next value is 0.2734. Fine. Now, so the value which is near to this is 0.2704. If you want, you can take the difference between this and this, and difference between this and this. Take the absolute value. Whichever is small, then that is nearer. That means clearly 0.2715 is near to 0.2704, because the difference is you are getting the 0.11. The difference is 0.0011. Whereas difference between this value and this value is 0.2734, means it is 0.0019 you are getting. So therefore this is least, and therefore we are considering this. So we take nearly equal to a of point how much 74, 0.74. Therefore z equals 0.74. Like this we can find the value of z. Like this we can use the table. Okay, now using this table we are finding the required probability, and the table is provided in the exam. If it is not provided, you can ask for it. Okay, in some case you may give a different table where these, instead of these values, you may find only like this. Instead of 0.00, just 0, 0.011, 2, 3, 4, 5, 6, 7, 8, 9. These value denote the second decimal place value. That's the only difference you can see. Okay, now I think it's clear that the how to look into the table in both the ways. And you can see that, look at this, the table ends at 3.4, because after that almost near, you can go up to 0.4, but normally you're not getting after that. So 0.4 means you're getting the complete value like that. That's why you can see that in the graph, which is standard normal table, so which you also seen in the previous video. So see, almost this coincides with this x-axis or z-axis. Look at this portion after -3. almost close. Therefore, then the area below, after that, you take 3.44 is 0 almost. Okay, that's why the table is given up to 3.4, not up to infinity. Fine. Now, if you uh, understand how to look into the table, okay, I think this from this example is very clear. So we can easily work with the problems. Now, we learn working procedure with the problems. Problems are very simple. So first we learn the working procedure. So working procedure is this. So you can understand the working procedure and also remember in the form of few steps. In the first step, what you have to do is we have to recognize the mean, which is mu, and the standard deviation, these two, given in the table, given in the problem, not table, problem. Most of the problems given this one. Also, we're getting one more kind of problems. I'll explain that later. Then we have to use the substitution. The substitution is this: put z equals x minus mu by sigma. This is a substitution which we already used. Okay. So while for converting probability in the variable x or an interval x1 to x2 to probability in the interval z1 to z2, there we use that substitution. So the same substitution we are using, and throughout this set of problems, this is the same substitution. There is no change in substitution. Then substitute for mu and sigma given in the problem. Okay. Then write the probability of the x, the condition on x less than, greater than, or in between. Okay. Now substituting here for x, find the corresponding value of z and then convert into probability in terms of z, p of z, maybe less than, greater than, or in between. Okay, then use the list of results which are given, which are recalled while working problems in a very simple way, and then use the table and find out the value. Okay, this is the working procedure. Okay, I think it's also clear now. Now we'll start with the problems. Now I'll start with simple problem where in the first thing I'm finding the value of z, straightforward problem. Okay, the problem is this: evaluate the following probabilities with the help of normal table, with the help of normal table. Okay, so first one, p of z greater than or equal to 0.85. Number two, p of minus 1.64 less than or equal to z less than or equal to 0.88. Minus 0.88. And number three, p of z less than or equal to minus 2.43. Number four, p of mod z less than or equal to 1.94. So I consider this problem with the purpose that which includes all possible types of probability values you come across z after converting from x to z. Okay. If you understand this problem, so then you can easily manage the problems on these the other problem, application problem on the normal distribution. Okay. Now, so now we consider table again. We'll recall the table because we have to make use of the table. Instead of going back to the previous column, we consider table. Okay, a table is this one, and which are enlarged, which I am enlarging. because this you can't see, whichever logic. Okay, I think now you can see this portion. Fine. Now, what is the first value to find out? P of z greater than or equal to 0.85. Number one, P of z greater than or equal to 0.85. The first one. Fine. Now, so I already told you that whenever z is greater than or equal to 0.85 means it is probability from that value 0.85 less than or equal to z less than infinity. So whenever you are given that z greater than or equal to something, but write the interval probability from that value to infinity. The z is from that value to infinity. Now look at this. So it is from positive value to positive value. How to write this in terms of area A of z, area below the standard normal curve, only in the positive interval. Okay, for which we can make use of the table. Very simple, which I explained. Positive to positive is A of upper limit or phi of upper limit, which is infinity here, minus A of lower limit. Here it is in case 0.85. Now this equals to A of infinity, we know that 0.5, the standard result. Area below the curve from 0 to infinity, which is same as area below from minus infinity to 0, which is both are equal to 0.5. So the complete area is 1, which already explained. Okay, minus A of 0.85, which are to get from the table. A of 0.85. Look for 0.8 here. Look for 0.8 here. The first column, this one. Next, you have to consider 0.05, the second decimal place, 0.05 here. Now, come down. Here you just point the direction. Intersection is this. And what is that value? Value is 0.3023. 0.3023. Now find this value, you're getting it as 0.1977. Okay, so we have got the first probability value. Now we find out P of minus 1.64 less than equal to z less than equal to minus 0.88. So it is a negative interval. So here we have to consider the corresponding positive counterpart, namely, which is equal to P of negative of this, that is becomes 0.88 less than equal to z less than equal to negative of this, that is 1.64. And now we have probability over a positive interval z1 to z2, which is equal to phi or a of upper limit, which is 1.64 minus phi of lower limit, which is 0.88, which equals to now phi of 1.64 or yeah 1.64. So look for 1.6 here, this one, and 0.0 for this one. You come down here. Okay. And this you move. This is the value, which is point 4495, which is 0.4495, 0.4495 minus 0.88, 0.8 here and 0.08 here. Just move in like this. So I think it is 0.3106, 0.3106. You simplify that, you take the difference, you get it. Next case is probability of z less than equal to 2 minus 2.43. Okay, so here we are taking z greater than equal to 0.85, which is converted as a this interval 0.85 to infinity. Similarly, z probability of z less than equal to some value means it is from minus infinity p of minus infinity to p of minus infinity less than z less than equal to minus 2.43. Now, now, so once again, the same as the previous case, negative interval. This is equal to probability of 2.43 less than z less than infinity, which equals to a of infinity or phi of infinity minus a of 2.43. Now, this equals to what is a of infinity, which is zero point 0.5 minus what is a of 2.43? First, consider 2.4 in the first column, which is 2.4 is here. Then 0.03 here, come down. So, so intersection of this one column is this, which is 0.4925. 0.4925. Simplify this. Thus turns out to be 0.0075. Okay, now we consider the last case. Last case is this one. P of mod z, probability of mod z less than equal to 1.94. Okay, I'll consider that one. Fourth case, P of mod z less than equal to 1.94. So when you are given like this, modulus of z less than equal to some constant, you get the interval which is from negative of this value to that value. That means this can be written as probability of minus 1.94 less than equal to z less than equal to 1.94. Okay, now we have got interval which is from negative to positive. So using the result, you can write it as a or phi of the upper limit, a of 1.94 plus, you're getting plus, not minus, like the previous case. If we consider a complete positive interval, which is a of upper limit minus a of lower limit. Here it is negative to positive, a of upper limit plus a of absolute value of this lower limit, which is always negative. Absolute limit leaves the negative sign. So you're getting 1.94, which is positive. Now both are same, so you can write twice you have 1.94. Now 2 into what is the of 1.94? We'll get from the table 1.9, then this is 4. So you have 1.94 is this 0.4738. 0.4738. If you multiply, you get the value as 0.9436. 9476, not 3676. That's how you can find the value. Here in this table, this problem, I explain how to get this probability if you are given there is this kind of probability values. Normally, you're not given like this directly. That means you're not asked to find out probability of z wealth is directly. Again, application problem where x is some variable, which is a normal one, and then we have to convert the standard normal value. We have to write in this form. Once we write in this respective form, we can find the respective probability easily. Okay, in the way what we did in this problem. Okay. That kind of problems, around 4 to 5 different kind of problems, we'll take up in the next. I'll explain that in the next video. Okay.